Hello, this is the Requirement and Library Finder, the final project for Gabriel, Guillen, and Zinoo Park, CSCI E29 Advanced Python, Fall 2019. Now, this is our brief introduction. However, put it simply, we were very frustrated with libraries and environments and dependencies always confusing us and breaking our code. So we wanted to provide a solution, create a solution so that we can see what is installed where or what is not installed where. So what is the problem? Again, some bits of code worked here, but it didn't work over there. And it's very easy to mix up your modules, libraries, requirements, dependencies, and etc. And it's also very, very frustrating to have to deal with this kind of situations, especially if you're not that greatly skilled at Python, like me, Zinoo. Which I would have no idea what I'm doing. So the objective is create a tool to help deal with required libraries. And the features are, number one, find libraries installed in main environment and libraries installed via pipenv. Find where the dependencies are installed pathwise, and show dependency tree. And as a last step, create graphs, the Venn diagram, and showing the environment information. So what packages do we use? We use more than these three packages, but these three are the backbone of what we did. So we chose to show only these three, especially Luigi. So this is the flow of things. We would use three files, the conda.json, the pip.json, and the pip-file log. And we would have Luigi process that, and then we would try to create Venn diagrams of dependencies as to where they're installed, in what environment they're installed. And we would also, as an end product, try to create a dependency tree, so-called the tree of life. So this is the Luigi process. As you can see, we take the conda.json, pips.json.json, and we would also take the pip.file, as you see over here. And then this is the next step, the validation, checking that they're all there. And this is the Venn graph. This function, or this step rather, would create a Venn diagram. And also the tree. It creates the dependency tree as an end product. So, and also you can check the dependency of one single item or multiple items or just everything all at once, depending on how or what you pass through as the parameter. So this is how you use it. For example, if you wanted to run everything, you would go python-m rqlib-all. Now, keep in mind that for simplicity purposes, we did not choose to run things in pipenv shell. We chose to just run it in bare Python shell, which makes things a lot easier because actually we're trying to gather all environments and libraries information, and that having all these things run in pipenv shell only complicates matters. So we chose to run it on Python, bare Python shell. And I will quickly demonstrate how it is done. So notice, for instance, that right now I have no files in this folder. However, if I go over there and type python-m rqlib-all, everything is returned and we get a happy smiley face. So we go back to the output file folder, and this is what we get. This is the dependency check for one single item. Because we didn't specify what we want, it tells us that there is nothing for us to see. However, if this is for every dependencies. So we have a list of these, all of them. And this is the dependency tree. Beautiful. And most intuitive end result, the Venn diagram. And also, you can just run separate processes as well, like this: python-m arculib-vg. This is supposed to give us a new Venn diagram. And then we have a smiley face. So we go back to the folder, and yes, we have a new Venn diagram. So this is how it works. And but one thing to keep in mind is the last thing. We use a timestamp to save files. However, when we only run the tree alone, Luigi has problems finding the file names with different timestamps on it, because the timestamps they vary by the second. So it's almost impossible for Luigi to go back to the already processed file and go on from there. So I suggest you disable the timestamp mode if you specifically want to run the tree alone. Again, this is the end result, screen capture of it. This is the product of Venn graph. It's in task.py and validation. This is the tree. Now, there were some limitations because due to time constraint and due to the various number of different environments and virtual environments and operating systems, it's very hard to, for now, it's very hard to design and develop the same for every single case. However, which is why for this case, it was in Anaconda on Windows. However, I think given enough resources and time, it may be very easy to scale, because as long as we know what goes and what doesn't go for each environment, we can just go around that so that they work. And this is the GitHub. Thank you for listening. Goodbye.